Andrew Carnegie. Oops, spelled his name. I want to do that. If you look at his history, uh, he definitely became someone like Jobs. If you had to say it, where he had all components, and the way he got this was very typical for this age, since there's, again, really it's kind of out of necessity, right? There's no supported infrastructure around. So he was a factory hand initially, obviously learning from other. Then he became a telegrapher, working in new technology at the time, which is a telegraph. That allowed him actually to then get more involved in the business because he was good at all those things. And he got involved. He was the secretary in the business, sort of an assistant to folks. And you got to remember, at the time there's not many people around and people are dying young. So he's doing this all in his teens actually. So remember how I was just describing in the current ecosystem how working for companies is going to give you the MIT knowledge. Again, nothing new from a historical point of view, since Andrew Carnegie did the same thing. What's very fascinating for the lectures we've been giving is that in order to innovate on a much more fundamental level, he had learned what we talk about. That, remember, I've given lectures talking about it in a new age when you have to innovate fresh after when there's really not a lot of knowledge around, and you need to go vertical. And so actually Andrew Carnegie went vertical, and when he finally jumped out, he went from mines to steel, whole way up, owning everything. And then even to, and I can relate to this, and it's the Qualcomm model, and even to kind of make the steel more valuable, he even vertically integrated into buying bridge companies. And that's because a bridge was a huge market and easy demonstration of the value of his steel. And of course, with all this, you can innovate in materials. And if you look at it, it's a very similar story of strained silicon, where because we were vertically integrated up to here, and then in our case, we worked very closely with early integrated circuits, allowed us to really advance that technology until the industry could really see it. And remember, the Qualcomm model was the same thing. And later on, in modern times, it appears that there are so many other companies that sometimes you can step back, and if different pieces get together and want that technology, license it. But here, you got to remember, these companies and the innovation required to go vertical, from essentially mining through processing materials, process everything else, and even getting steel, and then what to do with the steel from the steel, was all required to really innovate. And then Ford, people forget, all these guys, you get a little snippet, but using our innovation lens, it's fascinating. Most people don't realize that Ford was in Edison's lab. So this gets to our argument before about the lack of innovators in modern times, and about how it's going to take some time for innovators to propagate. And you can see here that Edison, clearly an early vertical innovator himself from that time period, people learned in his lab and then went out to do their own thing. And so Ford, after being in Edison's lab, he went out and he raised dollars for auto manufacturing. There you go. Not too afraid to open up market application space, because he learned probably lots of different technologies in Edison's lab. But then he saw the opportunity for market application of a lot of that knowledge in auto manufacturing, and jumped out and did it. And he was able to raise the dollars. And just to give you an idea that things are any different today in terms of getting hundreds, if not thousands, of people on board, it was 10 years to get to the real fundamental innovation, which is the Model T. So it did not happen overnight. It took 10 years to get to them. So in things that kind of people focus on that accelerated things, but are not solely responsible, of course, just like all these things, talking about here, examples. But the 1862, there was the Morrill Act, which is something people really, and it's important because it created places for the first time that focused away from the traditional learning model, liberal arts, if you will. And what it did was it helped establish, it was to promote agricultural. Remember, we were seeing that there is growth, in the 1700s, but by 1800, of course, everybody can see that there's massive growth going on. It's having impact all over the place in England too, kind of good and the bad, and where our society's going. It's very clear that this is a disruption. And so one of the ideas was, again, not knowing our model, but they're seeing, look, we need to have places where people can go and start to learn about MIT iteration, market implementation technology. They're not using those words, but look what they're doing. They see that machines are affecting agriculture. They're increasing productivity. And it's taking fewer people to feed more people. So what do? They create an institution to promote agricultural learning, and more importantly, the mechanical arts, again, showing you the influence of the industrial age, a paradigm, which we'll talk about in the next lecture. So these innovation paradigms are putting things in place to allow the beginning of understanding how to accumulate that we need in each of these areas. And certainly what they're recognizing is the understanding of technology piece, right? Because certainly trying to establish teaching universities to put T into the process. And of course, the probably the best known of the institutions, MIT, which is why MIT. If you go to Lobby 7, like we talked about in the advertisement for this class, if you look at that very first advertisement, it says in Lobby 7 on 77 Mass Ave, right around the top, that basically it's science and technology for the application in industry and agriculture. And so you're already basically setting up what should be the connection between the market applications, technology, and something that was a little bit less obvious and still is less obvious is the implementation piece. So, this was a huge factor, and also led a little bit later, and again, people don't fully appreciate this, but the success of the Morrill Act in creating educated people and seeing again that the growth is happening even faster, industrial age, everything else, created the opportunity to build later things like Bell Labs, etc., right, which I think was started to be formed around that. So again, this appreciation that there's something going on here, technology. So all of this is happening, remember, under this ability to constantly form and destroy different kinds of systems and associations and companies and everything else. Very different from the old world and much more accommodative of our innovation process. So with that early phase established, let's talk about the more modern system. So I kind of whipped through, America founding all the way up to Bell Labs in the 20s forming. Okay, so, but let's look maybe a little bit more modern and jump right up to the 30s and the 40s, and we're going to call that phase. Again, these are approximate years. You should not take these as the the exact dates, but the next phase of this lecture, I just want to give you approximate 20-year clips of kind of how things evolved, 20, 30-year pieces of how things evolved in the American innovation system. So I hope you can see that the foundation has certain principles, the fluidity of organizations and the ability for individuals to easily migrate and almost have to migrate out of necessity in order to find economic growth and to try to create a stable situation for their families. But also seeing that when they invent and they create innovations has a huge impact, and that again created a tinkering culture in early America, and that led all the way up to Bell Laboratories forming in the 1920s. Now in the 30s, a very important thing started happening, which was that I call it innovation itself, the innovation of nation-state research and technology investment. So you could see with the Morrill Act that people wanted to, they saw something happening, they want to support agriculture because they could see, hey, you know what, obviously people are starving less, and you forget that in 1800, 90-something% of the population had to work in agriculture. And then by, I think it's like the mid-1900s, I think there's 5-10%, and today it's less than 1% of the population is needed to supply. In the United States, it takes less than 1% to supply all the food to the United States, and we export. So clearly, people are seeing this trend, but it's all confined to kind of that agriculture. In fact, in the early 1900s, the largest part of the budget was agriculture, and the technology piece and especially research wasn't fully appreciated. But a man came along, and this is Bush, and notice he's smoking a pipe there. If you go down the MIT hallway, a lot of those early guys all seem to smoke pipes, especially in the sort of. And his name, by the way, is Vannevar Bush, and the easy way to remember that is that the MIT mascot is the beaver because it's nature's engineer. And so if you think about a beaver and think Vannevar, in fact, he really was upset that people would always get it wrong by saying as a Vannevar and all sorts of things like that, that he actually told people to call him Van in order to. Now, the name is kind of an odd name. You say, where did Vannevar come from? And it turns out that it was his father's roommate. So back then, the close relationship, a lot of localized, this bottom-up kind of society that America built, not a lot of top-down, relies a lot amongst the local folks. And so, his father, I think, was a minister or something like that, and went to small colleges in the Northeast, and from the Netherlands, I believe it was. And so back then, because you're very close and you think of things like that, you name your son after them. And so Vannevar was the last name of his father's friend in college. So with that little aside about making sure we pronounce his name right, he could see, he was a dean of engineering at MIT. And you got to remember, MIT was the only game in town pretty much at this time, because the Morrill Act created, MIT was in Boston, and remember, that's where America really grew out of the Northeast. And so there's multiple reasons, your critical mass there, but MIT became, the sort of leading from that act. And so he was a dean of engineering. And he actually could see that there's a revolution in physics. He could also see um, that there was a lot of things in electromagnetic space that were going to do two things. And initially it was obvious. And when you read Vannevar Bush's own work or works about him, you start to realize that I didn't really fully appreciate this until later, but even though World War I had finished, everyone, including many people obviously in the United States, never believed that it was over. And in fact, Compton, who was the MIT president, and Bush there was two things going on. They were very worried about the New Deal because it was more of a top-down thing than had America ever done before, and they were worried about the coming conflict in Europe. So it must have been fairly clear to everyone that things were not settled. Because in the 30s, Bush said there's a coming conflict. Got all this new physics, and it's going to change warfare. Now you got to understand, after World War I, they thought he was nuts because, and this I want to get to innovation paradigms. That's why it's so important to think about innovation paradigms. If you will, the innovation paradigm for war was mature. And you might remember World War I, things were kind of at a standstill. Remember, we had trench warfare, and it was very difficult once people dug in to really shift who could win. And you could create stalemates. And, you know, generals, for example, in the Army, because of this long period of time, they knew exactly how many men they need to do this, and we know how many mechanized vehicles we need for this. And these things were all considered mature. It's like, you know, the old paradigm maturing. What Bush was saying was that's all a bunch of nonsense, and that as soon as we start applying our new understanding in science and technology to warfare, and a good example is a timed fuse. You know, we think of these things as naturally today, but you didn't have timed fuses before where armament could detonate exactly under a particular condition or a particular event. And so that's a simple example of the many, 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 many ways in which the sort of new physics and understanding of EM and electronics and mechanics affected warfare. So it's a classic case of innovation itself. That's why I put, you know, it's really an innovation that the nation state best. So what Bush did was he got one general. This is just like a startup. He got one general that actually said he's not crazy, and got Roosevelt. Roosevelt. That's not correct. The So basically, it's the same thing with any. Remember, I was mentioning in the last sequence that you have to be contrarian when you're innovating because no one's going to believe what you're saying. So, in a way, Bush is kind of injecting the idea that opening up of technology and science space is going to cause innovation, warfare innovation, to converge in different ways than we thought before. And Roosevelt was like, definitely, I'm going to support you. And in fact, over time, he left MIT and he went to Washington to a place called the Carnegie Institute, which was, an institute in which he could operate both. He still had connections back to MIT, but basically became sort of like a, CTO for America, sort of in this time. And he convinced Roosevelt that you got to invest. Now, remember this time period. Talk about difficult time to invest. In the 30s is what I'm talking about right now. We had the Depression. And Bush is arguing that industry, government universities need to get together. And, of course, in our model, says that the information about this is distributed across those organizations. And if they get together, in our words, they could iterate and converge on these new warfare innovations faster than anyone else. And a consequence of that, you only hear about Oppenheimer and all this. Those are just one of many. All those projects, all that organization was started in the 30s. They started doing research work and came to fruition, thank God, just in time in the 40s in order to influence the war. And there's a long list of, radar, a classic case of actually MIT operating across the globe is that close collaboration with the British, and including our own industry, government, and university sectors, including MIT, which is, of course, famous for the Rad Lab. But obviously, atomic weapons, you can go through big ones, right? And then, like I said, there's like time fuse, which are some of the early ones. Economics, this is another interesting thing. There was an argument at the time that cost doesn't matter. And Bush, in his work after World War II, when he's kind of, writing as he got older, he pointed out that he always used to invoke, in our words, implementation, where cost is in the equation, because, he attributed Hitler's inability to execute because of some bad technology investments. And it's fascinating to read. But Bush was also very early in what I would call the importance of implementation in the innovation process. And actually, I think way ahead of his time, because probably through up until now, I actually think most people don't really understand that. Now today, of course, in modern research into defense, people are very aware, and over my lifetime I've become more aware of the importance of bringing those things to the market for defense. And that was not the case when I was in graduate school. So they're kind of catching up to what Bush knew a long time ago. So with these massive investments during the war and the success of the war, Bush's real big jump, second big jump, was saying that when the war ended, he knew from looking at previous, from history, that if all of that power that they needed to do this top-down stuff to make this happen and change warfare, if they kept it in place under the defense machine, it would be dangerous for the country. Bush was a big proponent about creating now government organizations that were not under the Defense Department. And so he's trying to kick out organizations that would invest in research and technology. And his argument was they needed to be outside from defense, and like the innovation that they brought to defense, they would now bring to the commercial marketplace. Hence, our beginning of our modern ecosystem, because one of the organizations, for example, that has lineage from that time was NSF, the National Science Foundations. That was part of, the funding mechanism inside DoD that was ejected out and put into the market, the government organization, but it was put and is not under DoD. And something else you should know is that Bush was part of a company that eventually became Raytheon. So using a private company in this age, remember that's a new phenomena, to take the results from investments in technology during World War II and to then try to create a private company to bring those to market in different ways. Now it turns out Raytheon ended up being a defense company and could never really get away, probably had a hard time opening up its market application space. Even in modern times, it's been trying to do that, and it's been difficult for them. But the point is that he innovated even in the mechanism for moving technology once the war was over into private company. And so there you have the beginning of what everyone does today, which is the nation-state investment in research and technology in order to create a potential future of economic. That was not really, I think, appreciated by modern times. Modern times doesn't appreciate how Vannevar Bush, really was a key factor in creating the system that all nation states tend to follow these days, which is that we must invest longer term in research and science in order to vibrant, advanced economy. So we'll stop there and we'll continue at the next phase, which is quite an expansion for the U.S. from 1950 to 1980 in the next lecture.